All right, we are wrapping up Trig Unit 2 with Day 5, Trig Equations. We're going to solve trig equations using our inverse trig functions. Solving trig equation often involves the use of inverse trig functions. In our case, it always will, which is why it's in this unit. So, example, solve the following problem, state solutions in exact radians. So 2 cosine of theta plus the square root of 3 equals 0. And basically you're going to solve this the way you would solve any problem. We want to first isolate the trig function, and then we're going to solve for our variable. In this case, our variable is our theta. So we're going to find an angle. Since our variable is an angle, the type of functions that give us angles as answers means we need to use an inverse trig function to find the answer. So first step, we want to isolate our trig function, which is cosine theta. So first thing we would do, just like if this were x here, you're going to subtract this. So you're going to subtract square root of 3. And then to get cosine of theta by itself, divide out the 2. And we get cosine of theta equals negative square root of 3 over 2. So notice we are not given any restrictions on this, and I'm going to get to that in a minute. But the bottom line is it means we're going to want to use, all students take calculus, we're going to want to find all our angles in the 4 quadrants that have this particular ratio. So cosine is adjacent over a hypotenuse. So we have square root of 3, 2. This gives us a 30-degree reference angle. So that means cosine, this is a negative ratio. Cosine's negative here and here. So we're looking at quadrants 3 and 4. I mean 2 and 3, sorry. So in 2 and 3 with 30-degree reference angles, this is going to be 180 minus 30, which is 150. And this is going to be 180 plus 30, which is 210. Those are our 2 reference angles. But remember, any coterminal of those 2 are also going to be solutions to this problem because they're all going to have the same ratio. So we're going to show this, since there's no restrictions on the range here, we're going to show this by, oh, it says exact radians. So first thing I'll do is convert these to radians. Pi over 6 is 30. 5 times 30 is 150, so 5 pi over 6 is 150. 7 times 30 is 210, so 7 pi over 6 is going to be 210. All right, so here's our solutions in radians. How do we incorporate all the coterminals? We just say at plus or minus 2 pi, plus or minus 2 pi. So that is this angle and all its coterminals, and this angle and all its coterminals. So unless you're given a range, and we will have a range in the next few, or in a few minutes, you should make sure that you give me all the solutions, which is the angles plus their coterminals. All right, you should try this one. Okay, solutions here, so you can check it. Here's my next example. 5 cosine theta minus 3 equals 0. Notice I am given a range. So this means I want the 2 positive or 2 negative quadrants in this case, and I don't need to add and subtract coterminals. So we're going to start the same way. We're going to isolate a cosine of theta by adding 3 first, and then we'll divide by 5, and we get 3/5 is equal to adjacent over hypotenuse. So we're going to see quickly we don't have an adjacent hypotenuse. We don't have a special triangle like that, so we will use our calculators. So we want to find the angle that has an adjacent of 3 and a hypotenuse of 5. So we're going to use inverse cosine. Inverse cosine gives us 53.1, but remember we're in the range 360, 0 to 360, so we want 2 angles. What did we get? We got the one in quadrant 1. Where else is cosine positive? It's positive in quadrant 4. This is basically our reference angle, so that means we have 53.1 degree reference angle. So that means the actual angle 306.9, or you could say negative 53.1 degrees. All right, that concludes the material. Here's one for you to try. See if you can get this correct. Other than that, you will have your worksheet is your homework. Bring your questions to class.